Hello everyone, I'm Dr. Shiv Kumar. Today we will discuss about the cement, sand and aggregates and about their properties. In general, this is the basic material which have been used in the construction, either it is making a reinforced member like foundation, columns, slabs, beams, etc. So all three materials when combined together in presence of water that makes the concrete. So as far as the structural framed structure is concerned, this material or the property of these material are very important. So we'll discuss about their properties, their size in this lecture. So let's start with the cement, sand and aggregate. So let's start with the properties of the material. The first property in this is density. The density is also called the unit weight of the substance. It is normally represented by the symbol called P. The density represents the compactness of the material, means particle to particle bonding. If the material is of higher density, it means the material is more compact. The density of construction material is the mass per unit volume of the material, and it is expressed in kilogram per cubic meter or lbs per cubic feet, and shows the compactness of the construction material. So by the density, we can get how compact the material is, and the intensity or the degree of compactness shows the strength of the construction material. The next is we can represent the density by this following formula: P is equal to M by V or is equal to 1 by V, where P represent the density of the material, M represent the mass, capital V represent the volume, and small v the specific volume, where 1 by V, which is used for the conversion kilogram per meter cube. Next is sand density. The density is cement. A cement is a binder, a substance used in construction that hardens and adhere to other materials to join them together. So basically, cement is a binding material which provides the adhesion. Also, it is make bond with the other materials like sand and gravels. The cement mixed with the fine aggregates produce mortar for masonry, or with sand and gravel produces concrete. Next, first density of the ratio of mass to volume. So it can be indicated in terms of kilogram per cubic meter, which is near about 1440 kilogram per meter cube for cement. Therefore, density is found for material and not for certain quantities. The next is sand density. This is another important material in mortar and also in the concrete. The density of sand utility returns sand density based on sand condition, whether it may be wet, it may be dry, it may be packed. So based on that, the density of sand varies widely. So it is totally based on the moisture content, and based on the packing, the density of sand may vary. For an example, loose sand. The density of loose sand is 1442 kilogram per cubic meter. It is dry sand and has been moved or agitated to lose the natural packaging process. The next is dry sand, whose density is 1602 kilogram per cubic meter. It is sand in its disturbed natural form, where it has been partially compacted by rain and gravity over time, but now it is dry. Next is pegged sand. The density of pegged sand is 1682 kilogram per cubic meter. That sand has been pegged manually or mechanically compacted. In this series, next is wet sand, which is having the 1922 kilogram per cubic meter density. This is the sand that has been in a natural and naturally compressed environment, and that is now wet due to water. Wet packed sand, 2082 kilogram per cubic meter. This is compacted sand that is also almost saturated with water, or you can say that the freshly sand which is procured from the river bed, running river bed. The next important material is aggregate. The aggregate is an aggregation of non-metallic minerals obtained in the form of particles and can be processed and used in the construction of civil engineering, structure, and also in road engineering. So aggregates are divided into or classified into two basic categories. The first one is the fine aggregates and second one is the coarse aggregate. As far as the aggregate is concerned, the natural sand that has been washed and sieved to remove particles larger than 5 mm is said to be the fine aggregate, or it's considered as the under fine aggregate. The next is coarse aggregate. The particle which are having the size more than 5 mm are defined as the coarse aggregate. The size of coarse aggregate may vary from 5 mm to 50 mm in size. The fine and coarse aggregate is delivered separately based on the requirement of the site or construction. Then, as they need to be sieved, a prepared mixture of fine and coarse aggregate is more expensive than the natural all-in aggregate. The reason is using a mixture of fine and coarse aggregate is that to combine them in the correct proportion in the concrete with very few voids or spaces can be made, and this reduces the amount of comparatively expensive cement needed to produce a strong concrete. The last is bulk density of the aggregate. The apparently density or unit weight of an aggregate is the mass or weight of the aggregate needed to fill a container with a specified unit volume. That is why bulk density is equal to, or you can say that the bulk density is the ratio of mass and volume. The main feature, if the volume is 1 unit, then bulk density is directly proportional or is equal to mass. Its unit is kilogram per cubic meter or lps per cubic feet. The approximate apparent density of the aggregate that is commonly used in the normal weight concrete is between 1200 to 1750 kilogram per cubic meter. So this is all about the cement, sand, and aggregates, which is the most important material in making of concrete or high strength concrete. So it is better to understand the basic physical property of these following materials. Otherwise, the structure, we cannot say that the structure is good or having the good quality or good strength properties. So we'll meet again in my new topic. We'll discuss about the batching of concrete. Till then, goodbye and thanks to all of you. Thank you.